Right in front of the porch.
Yeah,
Right
is
in front of the
anything
porch.
like right here? See it?
Oh, yeah, yeah. Tilt down a little.
It might be connected, but it's worth a shot.
That guy.
Oh, it's, you got it.
Got it.
Let's see what we got there. Hey.
I don't think that's altered. What do you think?
Well, that's the best chance we're going to get.
Okay. Going in the box. You have to push the box back out a little.
I think we got a couple likely candidates in there at least.
Roger. Yeah.
Delta.
Gone for box D.
Box E.
D, Delta.
D,
D is in Delta.
Okay, we're also going to start getting pulled because we're a little bit behind here.
Yeah, don't forget, I think our last sample to pull will be a Niskin. What's the
I think
elevation off the seafloor for that?
Yeah, 10 to 15 meters.
Okay.
Come up to 15 meters for a Niski.
Yep.
I think we might
all stop with the ship.
D.
Ridge, net.
Sorry, am I ND there? Yeah.
Are you
Yeah.
ND? Yeah, it looks like it.
Get in there, you.
Can we come to an all stop, please?
All right. I think after this we might need to change our watch name to Team Fast and Furious.
Yeah,
this watch has been just one thing after another.
Yeah.
There was a lot in that hour and a half.
Yeah, there
absolutely
really was.
It's like one of these football games where they score 2 touchdowns in the last 30 seconds.
Absolutely.
Yep. Okay, so we're getting ready to take a Niskin, and then we're going to drop ballast, and we're going to head up.
Roger that.
After we take this sample, we'll be pausing for our protocol.
15 meters. I've also got to, we also have a wrap in and a few other things, so.
Okay. You're coming up whether you want to or not.
Yeah, I sure am.
Are you racked back? So that's let's just make it official here. Officially off bottom.
Okay.
And let us know when you're ready to take a Niskin.
We're ready. 15 meters there.
There it is.
Show me the Niskin.
There's your.
Show me the Niskin.
15
Which
meters.
one am I
Sarah,
going
which
for?
one?
Oh, excuse me. Sorry. We are going for 3, 2, or 1. And Nav, can you give me depth and altitude since you just covered it up?
Call it, Steve.
Thank you.
Do we want to see the Niskins to make sure it goes?
Sure.
Yes, we do. Thank you.
This one is which one?
Which number was that on the blue?
That was 3.
3.
3. Thank you.
I can
Okay,
drop
when you
these
have
here,
a
right?
second, can you show me the ships so that I can see
Come out of
where
auto
he's
depth,
moving?
Gabby.
Come out of auto depth?
Yeah.
Okay.
You're coming up whether you want to or not.
Okay. Oh, I sure am. Can we get the wrap out before we do the whole recovery thing?
Absolutely.
Yeah, only got 2,000 meters to deal with that.
Okay.
So that was our last sample. So we are just dropping some ballast here, and then we are going to go off SPL for just a moment after this process is complete. The reason we're doing this is to conduct a private ceremonial protocol to acknowledge and honor the biocultural resources that are present and that we have been interacting with on this dive. We are going to be off SPL for just a moment, and then we'll be back with you.
Yes, they are. So, oh, yeah.
Okay.
All right, thank you for that. Thank you so much.
Made the most of that.
Yeah, we
Yeah.
did. We were getting some curveballs there, but
Yeah.
we were
Yeah.
holding tight as a team.
Yeah, good job, team.
Good job, team.
Dan, you did say that was number 3, right? For the Niskin?
Yes, that
Okay,
was the
thank you.
talking the talk, walking the walk.
Tectonic talkers, always talking the talk. Swim and swim.
So that concludes our exploration of the smaller seamount east of Don Quixote Seamount. We're at the northern end of what we believe this chain of seamounts could be the southern extension of the Wentworth Seamount chain. It's believed to have originated with the hot spot that would have started out up by Hessrise, correct?
I think so. So there's some.
Or even Shotsky.
Yeah, yeah. So we don't know for sure, but there's some. There's definitely some value in dating these rocks and figuring out, trying to deconvolve the story of all the footprints on the sand.
Right. And so we'll be exploring, we explored the first seamount on the southern end. That was our first dive. Then we transited north, mapping the summits of the seamounts in the chain. Came up to the northern end here, did a
Bridge, nav.
dive on Ha'eo Seamount. 2 dives there.
We're recovering the vehicles right now to be on deck at 0400.
We hope to get a few more dives in up
Thank
north
you.
here before we need to clear out on sometime Tuesday. It looks like we've got some large swell coming in. So the weather, the local weather will be fine. We're under a high pressure ridge. We'll see fairly calm winds, but the seas are going to build because swell moving in from the North Pacific. Deep low pressure systems crossing up around 40 north, sending swell down our way. Make it a little bit tricky for ROV launches and recoveries, so we can execute Plan B, do some seafloor mapping that we needed to do anyway on Tuesday and Wednesday. Then we'll return to our dives. That's the current thinking.
Yeah, so we could return to our dives on Thanksgiving.
Well, that'll give us all something to be thankful for. But we do expect more dives to be happening over the next day or two. There will be updates on nautiluslive.org as far as when we expect to be launching vehicles. And I do encourage you to tune in during launch and recovery. That is when we've seen the most action on some of the ship cams at the surface. It seems like the last few launches and recoveries, we've seen really interesting critters there up on the surface from the deck of the ship and from the cameras that are all around the ship.
Yeah, the immediate plan is to recover and launch again at noon local. We're on maintaining Hawaiian Standard Time on our expedition.
So your tectonic talkers watch will be launching you off on the next dive then. Keep your questions coming in at nautiluslive.org. Hearing from a couple of viewers that perhaps the live stream has kind of stabilized a little bit just in time for this blue water ascent. So hopefully we can reward those loyal viewers who have stuck with us through some tech problems with maybe something to see here. Who knows?
Interesting Argus view.
Yeah. Here you see the tether, which the ROV pilots are managing carefully throughout the dive.
Haven't seen anything recently on the wire cam.
Yeah, I haven't been keeping an eye on that.
So it's through that tether that we have power going down to Herc, and data and video coming up from Herc through the fiber optics. And up the steel cable that is attached to Argus, back to the ship, up to the satellite, down to Rhode Island, out
To all our wonderful viewers.
to our loyal viewers who are still with us for the blue water portion of our dive.
This is your chance to ask questions of the team about what we're doing or life aboard ship. I think we're all kind of a little dazed by the pace of that. I should just speak for myself and say that I'm a little dazed by the pace of that dive, but now we have a nice relaxing ascent here to get our wits about us and be ready to turn it around really quickly on the deck, get you back in the water around noon local time.
Maybe we'll have some more fin whales out there.
You know,
Yeah,
we can
that
hope.
would be great.
We can hope.
They are second in size only to the blue.
Yeah, that's what I heard.
They are endangered. The serious threat to them is ship strikes.
Oh,
That's not going to happen while we're on dynamic positioning.
Absolutely.
You said they're endangered? The fin
They are.
whales?
The
Aw.
fin, yep.
Yeah, we are following protocols that were established by the Papahanaumokuakea Marine Monument that govern our operations when we see whales or other wildlife. But when we have seen them, so far every time we've seen them, we have been using dynamic positioning, not the main ship's engines. So that has been an interesting coincidence. We haven't encountered them when we've really been underway that much.
They're probably staying clear, I think, as we're transiting. And they're probably curious when we're not.
So this was our fourth dive of the expedition?
Fourth,
Okay, it's all kind of blending together.
Blur's Day.
Blur's
Yeah, that's
Day.
right. Every day is Blur's Day. Our expedition, which has been underway for a week now. Happy 1 week anniversary.
Wow.
yeah, 1 week.
This expedition was granted a name by our partners at Papahanaumokuakea Marine Sanctuary and the Cultural Working Group. And the name that was given to this expedition in Olelo, Hawaiian is Lu'u'aea a Hiki'ika Papaku, which translates as go down, go up, go down, go up, until you reach the ocean floor, which is a very apt description of these quick turnaround dives that we've been doing.
Papaku being the ocean floor where the coral grow. And the deep water corals have been a focus, one of the focuses of this expedition. The other being the geology and microbiology.
Yeah.
So we do have several scientists aboard, as well as scientists joining from shore who are all exploring different questions. We just collected a few beautiful angular rocks right near the end of our dive. Andrea, can you talk a little bit about what the story of that rock is going from here when it arrives on deck, from when it arrives on deck on the ship to when it tells you its beautiful story? Can you talk a little bit about what that process will look like?
Yeah, so the rock does tell a wonderful story, and part of the story is the timing of events of when it was formed. So we take that rock and we take a slice of the rock, and then we try to find the least altered portion. We take that portion and we crush it up and we sieve it and we clean it in water, and then we put it through a magnetic separator to get the mineral phases that we want, and then we sieve it again. Then we clean it again, and then we take those mineral separates and we put them in an acid leaching program of multiple different leaches to get away the secondary alteration products. That will leave us with the crystal masses that are should be the crystallinity of origin when the rock initially cooled. Then we put those in under a binocular microscope, and we sit there and hand pick the cleanest and most the best targets for what we want. So if it's a plagioclase or a ground mass or whatever it is, we hand pick those until we get the mass that we need. And then those will be the crystals that are measured. We actually send them to a nuclear reactor where they are submerged and become irradiated. We let them cool off and put them into the noble gas mass spectrometer and measure them in heating steps that we call incremental heating steps. And then we heat them up, and then we heat them a little hotter and a little hotter. And as we do, they release their gas. And the gas that we are looking for is the argon, and it has multiple different isotopes. We analyze those isotopes, and we can define an age of that rock. Now, that method is not always successful, so sometimes we go through that entire process and we do not get an age. Sometimes on the good days we do, and then we can tell you how long ago that seamount formed. So it's a fairly involved process, but with a really great potential result.
Andrea, I have a question for you.
Mm-hmm.
So from the process of applying for funding to publish, or applying to funding, going out and collecting the rocks, dating them, analyzing the results, writing your paper or presenting and publishing the results, how long does that take?
Well, it depends on how many times you get rejected from National Science Foundation.
Right.
But so let's say you get say that you get funded and it's a grand day, and so then dependent on where your project is, if it's an ocean going experiment where you'll have to go collect rocks, you have to plan that expedition, collect those rocks, and then go through all those measurements. So that can take up to about 5 years.
Okay.
If they're rocks that you have on hand, so one good thing about the activity that we're doing here is that these rocks actually get sent to a repository. And so some of the scientists like me, I will use just a piece of the rock or a cut of the rock. And then the rest of the rock will stay there for other scientists that they might potentially use.
Okay.
So if you can use rocks that are in a repository, you can speed that process up. If you are doing a project on terrestrial rocks, so on the land, that might be a little bit faster as well. But definitely the process of dating a rock is not just you grab the rock and zap it with a laser. That would be great. Maybe we'll be able to do that one day.
Yeah, that's interesting. Thank you.
Uh-huh.
Which mineral phases are you interested in again?
So for these rocks, we'll probably look for plagioclase, and if the rock is not really altered with a lot of oxidation, we will also try what we call a ground mass, which is targeting the interstitial potassium in between the grain boundaries. So potassium is the chemical that we are looking at, and it decays to argon over time very consistently, like a very, very consistent and reliable clock. And so we're looking for potassium, and that potassium will decay to argon, and we want both the parent and daughter product to be measurable. So sometimes we use what's called a ground mass, and that is a whole bunch of small crystals. And so you're actually measuring the potassium in between the crystals. So in the faces in between the crystals as they grow together. So that yields a fairly good result sometimes. So, because that's a place where you can remove some of the alteration. But potassium does not want to go into the crystal. It's what's called incompatible. So it's one of the last chemicals to go into crystals when the rock is cooling. And that's why you can find it in between the grain boundaries. And in the last crystals to cool and crystallize while the rock is being formed or cooling.
So when you say that you have to pick the crystals individually using a microscope, how much sample do you need to get a result? Would you be able to see the whole sample?
So it depends on the noble gas mass spectrometer that you're putting the sample in, number one. Number two, it depends on the phase that you have. So an amphibole that's potassium rich, you will need less mass than you would a ground mass that has less potassium. A sanidine that has a lot of potassium, you will need less of. You can actually do single crystal sanidines.
Oh, wow.
Yeah, so it depends on the crystal phase and the noble gas mass spectrometer, but in general, right now for the lab that I'm working with, I target about 20 milligrams of material, but when I was first working as a PhD student, I was picking samples at 108 microns, which is very small and hard to see even in a binocular microscope, and I was picking approximately 100 milligrams.
Wow.
Which was a task. So now being able to pick at 250 microns, which is double the size, and only having to pick 20 milligrams, it's like, oh, my life has been revolutionized.
It still sounds quite involved.
Yeah, it can be, that's for sure. Well, it is a bummer when you go through all that and you can't get an age out of the rock, so you can see the data come in through because it's multiple heating steps. It takes, an entire day to make one measurement because each heating step takes time. And so, you can have a whole day of where you're thinking, oh, wow, I'm going to get a good age for this rock. I'm going to get an age. And then by the afternoon, you're hoping for some type of happy hour situation because that age has taken a tank and it doesn't look like anything that's going to be reportable.
And how often does that happen?
More often than I like.
Oh, no.
Well, because dating submarine rocks is difficult because one, they're low potassium, and two, they get altered. So the older the rock, the harder it is to date. The lower the potassium, the harder it is to date. The likeliness of alteration or alteration altogether makes it harder to date. So I was trained and specialized in dating these hard to date rocks. So the name of the game is that it's a game of numbers, and that's why I'm always saying more rocks, more better. Because even after you prep the rock and you give it due diligence and all the effort you have and all the expertise that you've gained, still might not be successful. So it is, in essence, a game of numbers when it comes right down to it, even though we use all our skills. And we're always looking to improve our skills. So we're looking to say, why did that age fail? What could we have done differently? We actually do experiments in the lab, trying to refine our method and seeing if we do this or tweak it that way or leach this or get a different mineral separate. What could it improve our chances of getting an age on a bulk rock?
Do you try to analyze multiple samples per rock?
We can do multiple phases per rock, so we can do like a plagioclase phase and a pyroxene phase and a ground mass phase all from the same rock and compare those ages and see if one failed versus another, if only one was successful, and try to figure out why that was. So that's some of the things that we do. Lately, we have found out that some alteration in plagioclase that we couldn't usually pull out of the mineral phase. We think that we can now because it gives a little milky color, and we think that was a source of some of the error on our ages. So it's something that we talk about a lot and think about a lot, especially after you can have some ages fail. You wonder, man, what could I have done differently to squeeze an age out of that rock?
What does it look like when you say ages fail? Do you get no number or just a weird number?
If you have incremental heating steps, you want to get to a point where each step gives an age and an error. And when you get to a point where each step is giving you a similar age or within error of the last heating step, you can count them together. So you want multiple heating steps that report the same age within error of each other. And if they make up a combined release of the gas that is 50% of the entire measurement. So every heating step altogether, we say that's a robust age. Statistically, 50% of the gas of that rock represented the same time stamp, essentially.
Okay.
And so if we get less than 50%, we don't consider that as robust statistically of an age.
Okay.
So if you see a plateau coming out and you're thinking, oh, this is going to be a great age, it's 30% of the gas, and all of a sudden it changes age, and it goes to a different reading, and then the next step, even a different reading, then that 30%, even though it shares the same age, is not as statistically robust.
Okay. All right. Thank you.
Andrea, do you have any expeditions planned to get more rocks to supplement what you're gathering on this Nautilus expedition?
Yes, so we have an expedition planned for January 2023 to go north to get some more rocks that might be the same, share the same plume
Okay.
as these rocks do. So trying to reconstruct an age progressive seamount chain.
Yeah.
And so hopefully we will have ages on some of these rocks, or at least have them prepped and getting ready for the mass spec before we go out and collect an additional set of rocks. So for that, one exciting thing about that is that we will be taking 8 undergraduate students out to sea.
Oh, that is exciting.
Yeah, to collect some rocks. So that's
really
from California State University Long Beach and University of Nevada, Las Vegas, where we are 2 minority serving institutions. So we're really excited about that.
And which vessel will you be on?
We don't know yet. We're still in the waiting list. We're in the queue.
Sounds like a lot of waiting in this field of geology.
Yes, there is. It's a lot of waiting and a lot of logistics, and that's why these rocks are so valuable. It's really hard to get rocks from the seafloor, especially targeted at features that you want to know about. So it's one great thing about the rock repositories of the world, where rocks will go, and future generations, if they come up with a new means of analyzing the chemistry in that rock, those rocks will be accessible to them. So it's a really important part of the work. I know there was an article that came out, I think it was in Nature a couple of years ago, and the title was something like, Stop Hoarding the Rocks, or something like that. Because some of the scientists get mad because it used to be that you would collect a rock and you would just keep it in your lab, right, until you retired, and then where does that rock go, right? So there's a big push to, as soon as you've used your rock and you've made your analysis, then you have the metadata, it should go to a rock repository where it can be used by future generations.
Yeah, I definitely agree with that. I think there's lots of applications in science and marine science, specifically oceanography, where a single data set can have many purposes and other people can use the same data set and get new information out of it.
Yeah, I agree. I think that's something that we really need to dedicate to future, planning, like NSF, programs to plan that activity, to leave those opportunities available.
Yeah.
Again, because you just never know what technology is going to bring forth and what kind of analysis you're going to have in the future. If you have all those rocks there, they're just available for those measurements.
And they're so expensive to get.
And they're so expensive to get. And right now, even as we speak, we have a rover on the Martian surface in an ancient lake bed, and its whole purpose is to collect rocks. It's trying to collect dozens of rocks, I think 40 rocks, and it's storing them in these little capsules. It's drilling holes into the surface of Mars, and then they will send another rover in some years, I think it's 3 to 6 years, to pick up those rocks and bring them back to the world, and that will be the first time we've collected rocks and brought them back from another planet.
That's incredible.
That's cool.
And the reason we know that it's in a ancient delta, that we know that it's in an ancient lake bed, is because we see the sedimentary features that are indicative of a certain environment. So just as I was talking about the sand ripples on the floor of the ocean today, they look at what is called the bottom sets, the foresets, and the top sets, which tell you that a delta was actually there before. And as soon as the sedimentologists saw that there were those formations there on Mars, they could confirm that indeed there was a large body of water there, because that is what is required for a delta to form. So we use geology around the solar system to try to understand and recreate the environments of not only this planet, but planets that are neighboring planets.
Have you worked with samples from the ocean drilling?
Yes, so my advisor is a big ocean drilling administrator, and has been for a long time, and a seagoer. And so we have some of the samples from the International Ocean Drilling Program are some of them that went through our lab when I was in graduate school. And right now, I think that the International Ocean Drilling Program is all packed with proposals, so it's not accepting proposals right now because of COVID. They got backed up and they couldn't sail. But those proposals are very big and involved, and because we're getting a time sequence, because you drill a core, that core has a temporal context. It already has some type of time indicated, because rocks, the oldest rocks are on the bottom. So the International Ocean Drilling Program has a very successful scientific group and background and culture and community that's really reconstructed a lot of Earth history from sediment cores taken from the ocean basins.
Long story short, geology takes time, and so does science.
Thanks for that.
I was making a joke with giving my talk, is that sometimes it makes you question your life choices. So you go through all that and you can't get an age. And it's a sad, sad time.
Hopefully that's balanced out by the happy dances when you
Yes.
do get an age.
Yes.
Well, we'll be looking for that in the coming months and years after this expedition, looking for your results. It's just awesome to think that those rock samples that we just picked up in those furious and on-the-fly moments could really rewrite the story about this region and how it formed.
Yeah.
So it's really exciting to be part of that.
Every time I pick up a rock, I always think the little rock that could. Because it's one little rock, but it could tell you so much, The little rock that could. And then sometimes I get ages back and I think about the little rock that did.
Thanks so much for that explanation. If you're just joining us on nautiluslive.org or any of our other platforms, we are rapidly ascending from the sea floor here. We are still at a depth of about 1,800 meters below the surface. We are in what we call the blue water part of the dive, and we're getting a viewer question. Thanks for your question, those of you tuning in. This might be a question for those of you who have been on Nautilus a number of times. When we're in this blue water part of the dive, which is either the descending part or the ascending part, which can last quite a while, this one we expect to be about 2 hours, how often during this blue water part do we see life? Do we see macroorganisms or animals? And would we ever stop an ascent if we saw something truly spectacular or something that we thought might be a new species?
I'm on. A lot of scientists have us have both cameras looking at the blue water, and we often slow the ascent or descent rate to something really painful, like 10 meters a minute per 1,000 meters, and they're actually videoing the marine snow and all the organisms that they see going by the camera. And although Gabby can probably tell you better what that actually is. But then some grad student gets to watch all that and identify the
Yeah.
what they see, and they characterize the mid-ocean, what's going on there. But there's also some highlight footage on the website. There's I think it's a blue whale or sperm whale.
Sperm whale.
Swimming around the ROV.
Very, very classic Nautilus footage from when we were in the Puerto Rico Trench, I guess. So a number of years ago now.
Oh, wow.
Where a sperm whale came to say hi.
Is that where it dove right in front of the ROV?
Yeah.
It did.
Oh.
Yeah.
So cool.
There's a lot of excitement.
In front of the ROV, under the ROV.
Yeah.
In the
It got really into the ROV. But there are, I wish I could tell you more about this project, but there are robots designed specifically to check out like the pelagic critters.
Mesobot.
Yeah, so like the last cruise that this that Nautilus did had Mesobot on board, which is an autonomous vehicle that specifically tracks through the water column gelatinous zooplankton, aka jellyfish, and it follows them around without direction. And I wasn't out, so I can't give you much more on that, but definitely projects exist to
It spotted the
do this.
little tiny microscopic crabs coming off the seabed at
Right, you were on for this
dawn
cruise.
and dusk. Yeah, so and they had some kind of very, very sensitive power sensor on there.
Okay.
And
PAR is a light sensor.
yeah, that
Photosynthetically active radiation.
Yeah.
So anything that's relevant to life, basically.
I think there are some mission updates on our website, nautiluslive.org, about that mission where they were testing these new technologies. So if you're interested in learning more, you can go check that out there.
Yeah, so this can be a snoozy sort of section of the watch, or it can be totally fascinating, depending on, you know, your proclivities.
Any other favorite blue water sightings from anyone that's sailed before?
we see a lot of towards the surface, especially right at that transition dawn and dusk. So we see a lot of creatures migrating. We see swarms of squid. We'll see the squid feeding.
The squid are very dramatic.
They're quite entertaining.
Yeah.
They're attracted to the lights of the ROVs.
I think I've seen some video of a Humboldt squid, which are like famously surly, attacking the arm.
Yeah,
Oh, wow.
they also they attack the lasers on the
Really?
seabed. Yeah, and when the laser hits a rock, they'll go grab the rock and pick it up and then fling it because they're disgusted. It's not something to eat.
So Dan isn't the only one flinging rocks on the ocean floor.
Yeah, it's quite entertaining. We see schools of fish sometimes so thick that you can't see past the end of the manipulator, and they'll actually swirl around the ROV and they'll school around and around and around, so they're coming through the lights and feeding on the critters that are attracted to the lights.
Is that where they got the idea for Sharknado, do you think?
Maybe. Not with this vehicle, but with some camera sleds I've worked on. We've had krill, like swarms so thick that you can't see, and then seals and other krill feeders feeding around the sled, and yeah, so that's a cool sort of midwater thing that you can see. I mean, really, you can't see beyond the krill most of the time, but seals will definitely feed near the lights. Use the lights to hunt.
The scariest one for us we see going through the water column is the big long siphonophores.
Yeah.
Because
Oh, they look like
kinda-
fishing line.
yeah, we're paranoid of line and rope because obviously we have spinny bits on the ROV and we get sucked in and bad things happen. So
They're amazing creatures, long colonial organisms. We did some blue water transects, actually. We purposefully went horizontally through the blue water off of the California Bight borderland with Amanda Netburn, is at the NOAA's Office of Ocean Exploration and Research, and she's That's her specialty. She's now detailed over to the White House. She's the Assistant Director for Ocean Science and Technology at the White House Office of Science and Technology Policy. But yeah, we were like, I don't remember the exact depth, 60 meters, 90 meters. We're doing gradual changes in depth and horizontal transects at those depths, but the siphonophores down there were incredible. Lots of them.
Definitely the most scariest creature in the ocean for me.
Definitely,
always gets me on the edge of my seat.
Yeah, definitely the gooeyest too. They get in the vehicle and sticky and.
Yep.
You go through swarms of jellyfish too. That can be pretty amazing too.
But yeah, Woods Hole got some private funding to specialize, just focus on the mesophotic zone, the ocean twilight zone.
Yeah, twilight zone. Very cool t-shirts those guys are sporting.
Yeah.
Mesobot shirts?
Yeah.
Yeah.
It's all about the t-shirts.
Oh,
Always.
absolutely. No question.
That's why I come out here.
Yeah.
For the same t-shirt every single time.
Oh, yeah.
I thought you came out here looking for trouble.
I was gutted I didn't get a Mesobot t-shirt. I promise I keep waiting for it to rock up in the mail, but
I think we could probably make that happen.
I've got an Alvin t-shirt, but I had to buy it.
yeah, me too.
So those who stuck around for the blue water part of recovery, was that yesterday, Stephen, that we you were quick with the camera change and saw the sharks traveling around her when we were recovering?
I was not.
That was on 8 to 12.
Yep.
No, it was
Okay.
on 4 to 8. The 4 to 8 watch saw that, and they bragged to us.
There's a lot of bragging.
Yeah, there was a lot of bragging.
I was pretty proud of getting the whale.
Yeah, oh
The
yeah.
whale
The
was pretty
whales
good.
on.
We will
Channel
not
3.
let 4 to 8 forget.
That's
we have
right.
The whales.
Yeah, Stephen wasn't even on shift yesterday when the fin whales were all around, right around sunset. You weren't even working, and you still made that happen. You got
Well,
the
I
camera
was
switched.
covering for Aaron.
Oh, it was
when he
dinner
went
relief.
for dinner, yeah.
Ah.
Dinner relief.
That's right.
So we have cameras all around the EV Nautilus. You can see there, if you're watching that feed 3, that's called the wire cam. We've been seeing white-tip sharks with some frequency from that camera, but yesterday right around sunset we saw some fin whale around the ship and got that up for our viewers. So if you were lucky enough and dedicated enough to be watching the blue water portion of that dive, you got a couple of sites there. You don't want to get your hopes up here or anything, but
Never know what you might
you
see.
never know. That's the whole point. That's the whole point of exploration.
Yeah. What about a colossal squid? I would
Sure.
really hope to see
Me too.
just a simply ginormous squid.
Me too.
Colossal squid or
would be
giant
up for that.
squid. Yeah,
Fighting
totally.
a sperm whale, locked in battle with a sperm whale. I think that would probably go viral. I think that might be our viral moment.
I think we could win the internet with that. Yeah.
So another question coming in about life aboard ship here. We are 43 souls on the Nautilus on this cruise. What's something about living and working on Nautilus that would surprise someone who has never sailed before?
Why don't we start with you? As your first time out, what
All
surprised
right.
you?
I think I'm the only newbie on this watch. What surprised me is how a team that has never necessarily worked together, there are lots of folks who have sailed before, but not necessarily in these combinations, just seamlessly came together. Everyone understands their job and their role. And from the very first dive, we made it happen. And so I don't know why that can't happen more in other parts of life and the world where people with the same goal can come together and each do their job and make it happen. I guess I thought that there was going to be a lot more like training, you know, preparation and perhaps rehearsal, but no, we just came here on the first dive and everybody sat in their chair and put on their headsets and made it happen. And all the folks who are not on watch or doing those other parts of their job and the crew and everybody understood their role and has been performing it from the very beginning. And to me, that was a delightful surprise.
That's pretty cool.
Yeah, you're all amazing.
Oh, shucks.
Oh, shucks.
This whole thing.
One thing that might surprise people is occasionally in your cabin where you have a porthole, if the seas are big and we're rolling, you get a underwater view from
Yes.
your head. Because
The washing machine
the
effect.
ship will roll and your porthole will go underwater for a few seconds.
That
Yes.
always
Come
freaks
back
me out.
out.
Yeah.
I love the washing machine effect. I think
It's-
that's pretty sweet.
It's mesmerizing. I'm lucky enough to have a porthole in my cabin this cruise, and that definitely shocked me the first time. I thought maybe we were in trouble, but
Okay, I've got one.
okay.
Green flashes do exist.
Oh, yeah.
They
Talk about that.
absolutely are real. There's a lot of talk about whether they're real or not. They're completely real.
Saw it with my own eyes.
This is my 4th season, and I saw the first green flash at sunrise the other day.
So what is a green flash? What causes it?
Physics? That's all I
I
got.
feel like Emil has a good.
Somebody know
Silence.
anything about?
There was a good theory on the last cruise. One of the scientists had your eyes are staring. I
At the
can't
sun.
do technical stuff, but because you're staring at the sun and the difference in the light, your eyes adjusting to the reds appearing or
I mean, it's
disappearing or
definitely true
something.
that like the green would be the opposite on the color wheel of the reds.
Yeah.
So that must have something to do with it.
So are you suggesting that if we filmed it with a camera,
We wouldn't see it.
we wouldn't see it?
I feel like
even
I've
if we saw
seen
with
it.
our eyes?
I feel
That
like I've
was
seen
his
it on.
theory. I'm not saying that's my theory.
Okay.
Yeah, I
think I've seen video of it actually.
It's physical. It happens.
Yeah.
It's not just the rod and cones reacting. Yeah, there's some scattering, there's some refraction that goes on. But for one brief moment, that green is the wavelength that's able to reach your eye. It has been photographed, but I don't think they don't do anywhere near the justice of what it looks like.
Yeah, so just at sunrise, or I understand it can happen at sunset, but when I saw it was a sunrise.
So it happens, it's more frequently seen at sunset because people know where to look for it. And
More people are awake for sunset.
but when you get an expedition leader who writes down sunrise time,
Yeah.
and you go out there and
Yep.
you can tell where it's going to come up on the ocean because you've got such a clear horizon. You get some treats. It's like a laser.
You get
Briefly.
some treats.
So
Yeah.
you have, there is photographs of it. It's a real
Yeah.
thing. It's a physical
Yes.
thing.
Yeah.
And so what are the mechanics of it?
I'm not going to nail this, but
Should we read?
some
Give
of
it a
the
whirl.
some of the longer wavelengths are absorbed, and the blue is scattered, and so just there's a moment when the sun is just beyond the horizon where the green is refracted into your view. Google it.
Yeah, there you go.
Make with
That
the
would be
Google.
cheating.
This is what Google is for.
Does it only happen at, like, can you only see it from the ocean?
You need but you need a clear horizon, and
Yeah, I've heard rumors that you'd see it more on a cloudy day. So that's not true? You need to clear, no clouds?
yeah, it's better to have no clouds.
We're
So
watching you Google it, Kate.
That's why I did it on this page.
Yep. Also me.
Why
There's
not?
a really good novel titled The Green Horizon about a guy in a sailboat.
All the best novels
Surprised you haven't
about
read
a person
that one,
in a
Gabby.
sailboat. Yeah,
That's
I
right.
do. This is the only nonfiction I can really get through is sailing nonfiction.
Anybody else, anything about living and working on Nautilus that might surprise someone who's never had the opportunity to sail on an expedition like this?
There's a gym
Yeah, there's a gym.
with a treadmill, a rowing machine.
There's a sign-up sheet.
elliptical.
Cookies
Join.
for dessert after
Free weights.
lunch. That always surprises me.
Oh, yeah.
Always
seabird,
disappointed when I go home. No cookies for dessert after lunch?
seabirds use us.
Yeah.
They use this ship to chase flying fish out of the bow wave and swoop down on them. That's what the red-footed boobies have been doing.
I mean, I'm just surprised that there are birds. We are so far from the nearest tiny specks
There
of
are
land.
birds everywhere.
It's amazing. We saw some albatross yesterday.
Yeah, there are always albatross for sure.
They're so funny. They remind me of, they look so dorky when they're
They're super dorky when they're landing.
landed,
Yeah, they put their little water ski feet out. I mean, they're ginormous water ski feet out.
And they
These
all
huge feet.
they all expect the ROV to be something to eat, so they hang around quite often when it's being launched or recovered, especially when it's being recovered.
Yeah, they can find it. Like if you're wanting
Yeah.
to know where Herc is coming up, you can just look for where all the albatross. There'll be like 100 albatross just
I've
clustered
seen
around
that.
where Arcus or Herc is going to come up.
They paddle over and look, and they'll get like real close to it.
Maybe it looks like a whale, like a dead whale floating to the
Super
surface.
dorky.
I haven't seen that here, but saw that off the Pacific Northwest, though. All the black-footed albatrosses
Yeah.
gather.
Particularly off the Pacific Northwest, there's huge colonies there in Oregon.
Waiting for the great yellow whale
That's right.
surface.
It's like, there must be something to eat here. For such elegant flyers, they're such dorky swimmers.
And their landings are so funny. They're like float planes.
Takeoffs are pretty cool too.
We had a storm petrel land during the previous expedition. Just rested for several hours on the ship, but they use their feet to walk so little. You know, they only go ashore to nest in a burrow, but they've got little webbed feet, and so if you didn't know that they had weak legs, you'd think it was injured. It was just kind of walking really funny around the social deck there. But it was fine. Just rested up, got back out there.
There's quite a bit of great information on the website of Papahānaumokuākea about the wildlife, especially the birds that are out here. This monument is huge. If you overlaid it on a map of the continental U.S., it would stretch from New Orleans to Las Vegas. But within that area, there's only 6 square miles above the surface of the ocean. And these seabirds concentrate there in huge numbers. You can see some great photos on the website, papahānaumokuākea.gov. And if you're not sure how to spell that, that's okay. You can go to our website, nautiluslive.org, and we have linked out to them. So you can go there and see some more information about these amazing seabirds that we've been encountering. Thanks for your questions. Keep them coming on nautiluslive.org. We'll do our best to give you a sense of what it's like to do this work or answer your other questions.
So right now we're set up for a half-hour early to the surface.
I saw that. Yeah, nice ascent rate.
Yeah, we need
With
to.
all those rocks, too.
Stick to 4.
We can,
we can slow it down, I guess, if we need to.
yeah, we should.
I
got a little.
Yeah, we're not
Carried
going to
away.
wake folks up early.
I got a little carried away pitching the weights there.
You got a little generous.
Yeah.
I'm going to pay for that from the boss too. I have
Well-
to stay after shift and rig weights up because they're painful to rig up.
No way.
Actions have consequences, but it allowed us to get those last couple of rock samples, so I think we'll call that worth it.
Considering the little issue with the dynamic positioning system at the beginning of our watch, the strong currents at the summit, you guys did an amazing job there.
Yeah, I didn't feel too bad about pushing it over time because
Yeah.
we did get bit there from the ship. So
Well, it looks like we made, we're
that's my
definitely not
excuse.
late.
Yeah, that's a great excuse. Well, I'll support you when we talk to the bus.
We're with you.
I'll be 100% behind you on that one.
I like that Precision Sea Star zoom.
Oh, yeah, that was nice.
Yeah, that was nice.
Did we get one of those?
We did not.
We didn't collect it. We just got some grabs of it.
Did they turn out nice? Like the bright red one.
Yeah.
correct?
Yeah.
We'll know after the dive.
Yeah, hard to
That's-
tell from here.
That's one of the things that the SCFs get to do. It's actually quite fun to go back through all those grabs. There are
Yeah.
hundreds and hundreds, but seeing, kind of reliving the dive, but also seeing what the other watches may have encountered.
Yeah.
And that's something that I didn't know would be a great part of this. You know, it's kind of, maybe some people would see it as tedious, but I see it as kind of like getting to replay all the dives.
I went through a couple from the previous dive today. Actually, it was pretty fun.
So have you figured out a way to do that without going through the web browser? Is there where you can do it through Windows Explorer?
If you scan your computer and show your scan to our data engineer, Justin, he will let you use an Ethernet cable to plug into the network, and then you can just navigate to the folder, and then you can just easily bring it up and rotate through them.
Okay, so yeah, we were thinking
you have
about
to be on the data network. That's why.
Oh, so ROV computer is not on the data network?
No, it's on the instrument network and public.
But you should be able to get, they're
From the
all,
lab.
they're all just
exactly.
So
they virtual, they're just VLANs.
Yeah, they should be able to, and I think they're all synced into a shared network that's available on the public drive. So.
Oh yeah.
Or the equivalent public drive. I'm not sure.
Well, we were trying to get
share.
We were trying to get to the folder using Explorer, and we failed. And we could go through ShipHouse through the web interface, but it's
tedious.
We'll have to.
Slow.
We'll pick Justin's brain. We got too scrambly to get the DSC running this dive. Next dive though, I really want to get that set up. That Brazingid would have been a great shot if I hadn't been or the sponge, because it's going to be kind of blown out on the capture likely.
Oh, you never know. Let's keep hope in our hearts.
Yeah.
I took a whole bunch.
For ONC, I was able to pull Argus, what was the record there? I think 80 meters at 3,000 or 2,500.
Uh-huh.
I could pull the Argus 80 meters away from the back of the boat.
I've definitely seen that. I've seen 100 meters.
100 meters?
Yeah, I think we got 100 meters. Though that may have been with a ridiculously long tether. I remember like an ONC a number of years ago doing 100.
Well, yeah, we had the 50-meter tether on, but we couldn't get any closer than, we couldn't get our vessel any closer than 300 meters to the lay vessel.
Right, so you had to lay Argus out.
But
it also, did you have trouble with...
I was able to pull Argus out enough. We were trying to get a sonar hit on a...
But did you have trouble with Herc doing a lot of this while you were pulling?
Yeah.
Yeah, so it's not a great way to get video, but you can do it.
Sebastian, we got 500 meters.
Is Sebastian a single body or two body?
Single body. And Ropos, we can get about 250. But those, both those vehicles got twice the horsepower.
So we're hearing from another loyal listener that apparently in one of Jules Verne's less famous novels, which is called The Green Ray, it says that once you've seen a green flash, you will never go wrong in matters of the heart again.
Wow.
So, I guess
such a good omen.
Yeah, I guess we're doing good.
I like it.
Fantastic. Thanks so much for sharing that.
Yeah, thank you. I haven't read that one.
You've read that one?
Have not.
Oh.
Yeah, Le Rayon Vert is the French name of that one. So there you go. I might have to check it out.
Yeah, I was on the hunt for a new, searching around in Kindle Unlimited last night.
Oh man, well you'll have to get it and give us the cliff notes during the other blue water phases of our dives.
I think Dan should just read it out loud during the blue water.
Oh, there you go. Story time with Dan. Oh, that's what our viewers want. That's really what they want.
I'm used to it. I'm reading to my kids before they could talk.
Yeah, blue water reading with Dan.
Oh, yes. I think that could totally be a thing.
Could be a thing.
Yeah.
All right.
Maybe I'll get more than 2 viewers.
This is going to take off.
my own cult following.
Yeah, or maybe your own show, you know, like reading Rainbow.
Yeah.
Yeah.
I'm
So-
just imagining a really soothing reading voice